Hey there and welcome to this Godot Dedicated server crash course. In this course, you're going to be learning how to make a simple game and a dedicated server for it, also hosted on a VPS so that you and your friends can play. This course will also be available on Udemy, so do well to check it out and leave a positive review for me. With all that said, let's get right into the tutorial. So before we get into coding, I want you to know and understand what client and server is. So the client is basically the game and the server is basically what is helping you to connect to other players. So now the server has an IP address and the code you're using is going to run it on a port. So now this port is like, for example, IP address is the house or let's say a building, and the port is like the apartment where a party is happening. So the client wants to go to the building first, then go to the port. So this port can be basically a random number or something. Some ports are being used anyways, but for preferences, I like using 4242 because I don't know, it's just a really cool number. But you can use things like 13900 or 69700. I'm not sure about that one, don't quote me on that, but basically almost any random number will work. If it doesn't work, just try changing the ports, try changing the last digits or something. So when the client successfully connects to the server with its IP address, it's going to be able to send RPC calls. So that means remote procedural calls. So now this helps talk to the server and talk to other nodes. So now some methods we're going to be using in Godot, which are RPC ID underscore ID, and this is to basically send particular information to a particular client. So the ID of one is always the server. So when each client is being connected to a server, let's say there's another client here. Sorry, pardon my drawing. This is another client. When it connects to the server, it's giving an ID. So this ID is basically almost random. And also this guy too is given an ID. But in Godot, the server always has an ID of one. I don't know if this is everywhere with servers, but in Godot, the server always has an ID of one. So if you want to send a remote procedure call from a client to the server, we use ID of one. Or if you want to broadcast it, you use the ID of 0. So there are many other RPC calls out there, RPC unreliable and all that. And I'll explain them as I'm coding throughout the tutorial. But I just want you to understand the basic concept of connecting the client to the server and how their IDs are given. The client's IDs are always random numbers, and it changes every time you connect. But the server ID is always one. So first of all, before you can get started, you need to have two Godot open, I guess. So first one is going to be the client, as you can see at the top left, and the second one is going to be a server. So the server is where, as I said, all the clients will be connecting to so that we can interact with each other. So here in the clients, we have our lobby scene and we have color X and a join button. So now, before we go further, I want you to make this script here called server. And you can just do it by right clicking, click new script and name it server.gd. So now this is the script that is going to be interacting toe to toe with our server. And we have to go to projects, project settings, auto load, and we'll get to import it as an auto loaded script. That's it there. So we're going to name server. Please make sure this thing is a capital S, because if it's not, you might run into some problems. Or you can make it a small s, and I'll tell you where else we need to make the other server the same name with this one, basically. So we add that, and we go to our other server Godot screen here open, and we're going to make other node, and now this node is going to be named server. So remember when I said use a capital S, this is why. If you use the small s there, just change this to a small s and you'll be all good. So we're going to save this server.tscn, add a script, server.gd, and over here on the ready function is where we're going to be creating the server. So there are two ways to make a server, whether using a WebSocket server or using the default multiplayer API made by Godot. So first off, I'm going to start with the multiplayer API, then go to the WebSocket. So first off, we're going to change this ready function to with multiplayer API. We're going to initialize the server by doing network multiplayer innet.new. Then we're going to create a server with the port 4242. Remember when I said I like that port? And we're going to store it in a variable error so that in case there's any error, we can spot it and try to fix it. Then over here, if error is not equals to okay, that means if the server could not be created for some reason, probably the port is already in use or something, then we want to print unable to start server. Then we return. But if the server is okay, we set the current trees network pair to be equal to server. Then we do get tree.connect network pair connected to underscore player connected. So this is just going to basically check whenever a new pair is connected and connect the function to this. Also, we connect the disconnected signal so that we'll get alerted if the pair disconnects. And if all is good, we're going to print server created. Then on the player connected signal, it's going to take in a variable ID. And remember when I told you that that ID is going to be completely random. So we're going to take in the variable ID and just print player connected. Then on disconnected, we're going to print again player ID disconnected or whatever you want to print it. So this is probably everything to create a server. I hope I'm not wrong with that. That's using the multiplayer API. And we want to start this on the ready. So we say func underscore ready with multiplayer API, and this should work. So we're just going to run this select current as the default scene, and it runs, and here in the console you can see server created. So we're done with the server right now. We go back to the client project, we go to script. Inside the server.gd script, we want to do some things. On the join server function, we're going to create a client with the network multiplier ethernet object. Then we're going to create a client using this IP address, and this IP address is the IP address of your current computer. So you don't have to set up the server first on a VPS or look. You can do it on your local machine with this IP address. And as I said, we have to connect to the same port, which is 4242. And if the error is not okay, then we'll have to print unable to connect and return. But if it's okay, we set the network pair into the client. So before we can run this script, we have to call the join server, and we're going to call it from the lobby where we press the join button. We want server.join server. So remember the last time in the server we had to connect some signals. Here we're going to connect it on the ready. So we do func underscore ready. And we're going to connect the connected to server, server disconnected, and connection failed, just so that we can debug properly, and if it's not connecting, we know why. And we basically do the same similar thing. On connected to server, we print connected to server. On server disconnected, same thing. So with all this done with the client and the server, we're finally ready for testing. But before that, Godot has a debugger problem where if you're running two files, it's going to show something like debugger is connected on your remote, something of that sort. So go over to editor settings, and we're going to change one of them. So this guy is on the 610 now, and the server is going to be on a 6007. It's not a must that it has to be the same remote ports, but you can just play around with these values and see the one that works for you. So anyways, we run it again. We run the server, and we go over to the client and run the client. And now if we did everything well, make sure you connect your join pressed, and we click join again when you see we're connected to the server successfully. So this is how to do we go around with the network multiplayer init part. So I'm going to go over to the WebSocket client part now. In the server side, the WebSocket part, you're going to just create a function with WebSocket. You must not create this function. You can just put it inside the ready if you want to use WebSocket server for the entire game or something. Then you're going to create a server with the WebSocket server object. Then the same thing, error is going to be equal to server.listen. But the difference is here you listen and here you just create a server. So you're going to listen on port 4242, and this is just basically an empty post string array, and at the end here is true. So this you don't actually have to worry about this, but this is true. The reason why we're doing this is because you must not put it anyways, but it helps us change the WebSocket server to a Godot multiplayer API. The Godot multiplayer API helps us communicate a lot easier and a lot development friendly, if you ask me. So basically, it's going to be the same thing with your multiplayer API one. So that's why we put it through there. So if error is not okay, then we start the server, then set process to false and return. The reason why we're setting process to false, I'll tell you in a minute. But just set process to false. Then we're going to set the trees network pair if the error is okay. We set the network pair to server Then we connect the signals, pair connected and pair disconnected. And over here, I want to tell you why this set process is here. So on a WebSocket server, on the process function, you have to always pull or poll. I don't know how to pronounce that. So here we're going to have to do func underscore process, and we say client dot poll. Sorry, server. But as you can see, server is not identified. So we're going to get rid of this, and we're going to put var server here. So now server is now a global variable and can be accessed through the two functions. And on the ready, we're just going to change this to with WebSocket. Hopefully we are done, and hopefully that's all you need to do to change this from a multiplayer API to a WebSocket, but it's basically still the same thing. So on the client project, first of all, we're going to declare a variable client up here, and up here we're going to, in the ready function, we're going to set underscore process to false, so that the process function won't get run until we tell it to do so. Here in the join server, so here we create a new WebSocket client object. Remember the other one was WebSocket server, but this one is going to be WebSocket client. The next thing is we're going to set error to be equal to client.connect to URL. So we're going to connect to the IP address and the port. As you can see, port is 4242. So you're going to do the IP address colon and the port. Then, as I said, post string array, you don't really need this. You don't need to change anything. You just put it as empty. And true is to make the WebSocket clients to behave like a multiplayer API. If error is not equals to OK, then we're going to print unable to connect, and we're going to return. Else, we're going to set the network pair to client, and we're going to set the process function to true. Now, the process function, again, we'll have to still poll. So on the process function, we're going to do client dot poll. Don't look at this as inefficient code because it's on the process function. This is actually what the high level multiplier does. It's just that you're not seeing it and you're not typing it in. Anyways, it's going to work. Let's just try by clicking play on the client and play on the server. So we're going to go back to the client, join game, and you can see player connected. As I said, a random long number, and on the client you're going to see connected to server. So this is how to connect with WebSockets and multiplayer API with Godot. For the rest of this tutorial, I'm going to just be strictly using multiplayer API, but it's also the same thing if you want to still follow along. Just do everything I do, but remember to change this part of your code and that part of the server too. So yeah, I think that's it. Thanks for watching. See you guys next time. Smash subscribe. In this tutorial, we're going to be making the player and the other players getting ready for the next tutorial where we're going to be instancing them in the game. So first off, I made a folder here called objects. So just make that, and we're going to make a new scene, and it's going to be a kinematic body, and you can rename this to player. So now we'll add a collision shape and add a sprite. So the collision shape is going to be a circle, and the sprite is going to be from the assets, and over here sprite sheet characters. We're going to drag it in. We're going to turn on region to enabled, and if you want to get this texture, it's on my GitHub, or shout out to Kenny Assets for this awesome asset packs. They are free to use. Link will be in the description, or you can get the same ones I'm using from GitHub. So I'm going to go ahead here and select the particular character I want. Then we'll increase the collision shape just so that I can fill in the character here, and we should be all good. We're going to save it player.tscn in the objects folder, and we're all good. The next thing is we're going to add a timer, and we're going to set the timer to 0.03 seconds. So here you're going to see a warning, but just ignore it. We're going to select the player node, go over to node, go over to groups, and we're going to name these players. And we're going to add it to that group. So we're going to be using this later in the series, not now. Anyways, we're going to add the scripts to the player objects. So in the player, we want to set two variables, velocity and speed. So velocity is going to be a vector 2 and speed is going to be a 200. Then on the physics process, we set the variable x to the get action strength ui underscore right minus ui left. That's just basically subtracting which keys we are pressing from each other. If you want to actually know what's happening here in depth, you can check out my other tutorial. I'm going to leave a card to it right now at the right, so you can check it out and see how to make a top-down shooter. But I'm not going to go into details because I want to focus solely on multiplayer in this series. So then we set the velocity to vector 2 x and y dot normalized. Then after that, we move and slide with velocity times speed, and we want to look at the mouse position. So basically, that's all we need to do in the physics process. Then this timer, we're going to be using it in the next tutorial, and I'll show you what that is for. But for now, we're done with the player script. So now I want you to go over to object, go over to player.tscn and duplicate the scene. So we're going to name this other player and we're going to open it up. We're going to remove the script attached and we're going to remove the timer. Also, the sprite, I want to change it so that our player won't look like everybody else. So I'm just going to select this blue guy here. With that done, we press save and we're going to add a twin here. Also, I will explain why we're adding a twin here in the next tutorial. But for now, just follow my lead and add a twin. And basically, the other players node is all good. We're going to rename this to other player and add a script other player.gd. In this script, we're going to set all these variables. The first one is twin, which is going to be equal to our twin node, sorry, capital T. Then the speed is going to be equal to 200. Puppet position is going to be equal to a vector 2. Basically, what the other player node is doing is going to be the kind of puppet player for other nodes. So to really explain this well, for example, here we have a two game instances, client 1 and client 2, and the server is talking to both of them. So now I indicated the owner of the client by shading the head. So the client 1 is going to be controlling this client over here, and this other person is client 2 that is going to be controlling. So basically what is going to be happening is client 1 is going to send a position rotation to the server, and the server is going to tell this guy, oh, move this other person with that position and rotation. So basically that's what he's doing. Then this guy client 2 is going to talk to the server and be like, okay, I've moved from here to here, and the server is going to tell everybody else in the network that, oh, move this puppet to anywhere with that position and rotation. So the server is going to be telling the client where to move this other player, and this is the other player.tscn that we are making right now, and this is the player.tscn, if you understand my point. Hopefully you understand it, so we'll go back to the tutorial. So this puppet position, puppet rotation, and puppet velocity is going to be collected from the server, and this is the puppet's player that we're going to be moving from. So after all this, we're going to create a function called new puppet position, which is going to take in a value of the puppet position. Then it's going to set the value to puppet position, and the twin is going to interpolate between the position it was before and the position it is right now. So it's going to give it some kind of smoothing effect in case the other person's network is slow or something. It somehow lag compensates whatever is happening. Then over here we add an update transform function, which is going to take in puppet position, rotation, and velocity, and it's going to set the puppet position and set the puppet rotation and velocity. Then last but not the least, in the physics process function, rotation degrees is going to be equal to an interpolated version of the rotation degrees and the proper rotation. So whatever rotation it was before is going to smoothly turn, and as I said, for lag compensation, so that the game will not be unplayable for if one person doesn't have the right network connection or something. So basically we save this, and I think that should be all for what we need to do in this tutorial. So stay tuned, because in the next tutorial we're going to be instancing the players, and other players are going to be joining, colliding with each other and all that stuff. So yeah, I think that's it. Thanks for watching. See you guys next time. Smash subscribe for part. In this tutorial, we're going to be instancing the players that we made in the last tutorial. I'll also make sure they can move around and collide with each other. So we'll go over to the lobby, and in the script, first of all, after we join the server, we want to set the join button to disabled, just so that we can click the join button twice. Next up, we go over to the server, and on the connected to server, we just want to hide the lobby. And on connection failed, we're going to just set the join button disabled to false so that we can actually press it again. Also on the disconnected, we're just going to, instead of hide, we're going to show. The next thing is we're going to go back to the rest directory here and create a new script. This script is going to be called global, and the global script is going to be autoloaded. So we go back to project settings, autoload, and we're going to add it there. When you open it, we're going to create a function called instance node, and this is basically going to be instancing nodes for us, because it's kind of a long process, and we're going to be instancing players, bullets, things very often. So it's actually more advisable to create a function for that, which is the instance node function, which takes in the node, the parent, and the location. Basically, it's going to instance the node in this first line and set the location and set the global position to the location. Then it's going to add it as a child of the parent that is specified up here, and it returns the node instance. Pretty easy stuff. So with that done, we'll go over to the server. And on the player connected, we're just going to send an RPC call to everybody in the network. That's what this 0 stands for. I'm going to tell it to call the instance player function with the ID and this position here. This is just a hard-coded position, but as time goes on, I'm going to create spawn points and all that stuff. So for now, we're just going to call this function on the client side. So we'll go back there. But before we do that, we're going to create another script, and I'm just going to call this nodes. Actually, this is the parent where we're going to be adding all the players and all the bullets and all that too. So also we go over to project settings, auto load, and call it there. So over here in the server.gd, up here we're going to just preload those players and other players. So we say var player is going to be equal to preloaded version of the scene player.tsn, and we're going to copy and paste this. Just name this other player, and also here other player. So now remember, we're calling this instance player. So in the client, we're going to use a remote function so that the server can be able to call it, and it's going to have an ID and a location. So inside here, we're going to set p to player if the get network unique ID is equal to ID, which basically is saying if it's me that is playing the game, then instance the player. If not, instance the other player. So that's actually what is going to make it possible that your character is this player and the other guys in your scene are these players. So this line here, this if, is basically going to check for that. If the current ID is equal to your ID, then instance the player. If not, instance the other player basically. So player instance is going to be equal to global the instance node p, and this p is basically this p here, and it's going to instance it as a child of the nodes script that we made here, the auto-loaded script, and it's going to instance it at that location. Next up, we set the player instance name to string ID, which is just going to set it to ID. Please don't miss this step because you're going to run into some problems in the future. The next thing is we're going to also check again if you are the player that just connected. Then it's going to look through all the other pairs that have connected in the past. That's to allow such that if you instance yourself in the scene late, you also be able to instance the other people that has already been there before. So we're going to look through all the connected pairs. Then we're going to make sure I is not equals 1. That's like, make sure we're not talking about the server because we don't want to instance the player for the server. Then we just want to call that function again, instance player, with I and with location. Basically, it's just going to go back and forth in a kind of loop form until it completely instances all the players. So with all that said and all that done, we're going to click play just to run the file here. I'll go over to the server. Before I run it, I just want to go over to um project settings and go to window. And I want to reduce the size because it's unnecessarily big. So I can actually put it 100 by 100 because it's a server and we don't even need the window. So we can run it. You can see how small it is there. Server created. Go over here and join game. You can see instance the player. And to instance another player, we're just going to move this guy around here. So we're going to create another Godot instance. Run the game. Join the game. And as you can see, we have another guy here. But as you can see, their positions are not updating in real time. We just know that okay, there is somebody else, and that's actually what we want to do now. So to do that, first off, we go over to the player.gd and sorry, the player.tsn, and this time we're going to connect the timeout signal to the player script. And over here, we're going to send an RPC unreliable ID, which is going to send it to 1, which is the server basically. And we're going to call the function update transform. We'll send the global position, rotation, and the velocity of our player. So we'll go to the server, and then the update transform function is going to take a position, rotation, and velocity. And after that, we're going to get the player that sent it. So to get the player's ID that sent it, we just use get string rpc sender ID, and we're going to get the player, and we're going to tell every other person with rpc unreliable we should update that particular player's transform and in there we're going to give it the player ID, that's the player that I want to move, the position and the rotation and velocity of that player. If you don't understand what this RPC or reliable ID, I recommend the first tutorial on this series because I actually covered all that there with all the RPC calls. So as you all know by now, if we are sending an RPC call, we have to go and create the function on the other end. So we go here to the client side, and on the server, scroll down. So over here, we'll create a remote function update player transform, which is going to take the ID, position, rotation, and velocity. Then we'll basically check if we are the ones that send this RPC call. That's basically saying if the player we're trying to move is not myself, then we'll call the node and we're going to get the string of that ID, which as I said here, this line is essential. So we're going to set the name to the ID over here when we instance the player so that we can actually call it here. So we call the node and we're going to call the update transform function because as you can see, the only kind of people that are going to be allowed for this are the other players, not the person that is currently playing the game on that client. So on other player.gd, update the transform, and as you can see here, I cover all this in the last tutorial. So if you haven't watched it and you want to follow along, go ahead and watch it. All this code will be available on GitHub anyways. So we call the update transform. It basically moves this player on the other client. This thing is quite hard for you to grasp on. Actually, I recommend that other tutorial if you want to really understand this part of it. There will be timestamps in the description of that tutorial, so you can go check it out. We are almost ready to run the game, but the last thing is on the player script here, on the player scene here, we're going to go over to the timer and we're going to click auto start so that it can start at the beginning of the game. So with that being done, we're going to run the server now and go ahead and run the client. We're going to join game here. I'm going to create another Godot, then we'll run it on this side too. So on this one, we're going to join the game. As you can see, here we are, and I can move. As you can see, the rotation too is being updated as we are moving around. So with that being said, this is all done. But as you can see, if we close one window, the players are still here. So we want to make it such that if a player disconnects, it's going to remove that player. So on the player disconnected, we're just going to call delete object ID, and this is just basically going to send it to all the peers in the network. So on the delete object function, we're going to check if node has that node that we want to delete. If it does, then we just free it, and this is going to delete the player object basically, and it's going to delete it from every client in the network. So with that done, we can run the scene here and also run another instance. Last thing, run the server. So I can join game here, join game here. As you can see, I can move this guy, move over here. And when I close that window, yeah, he gets deleted from this scene too because he's disconnected and we can no more interact with him. Basically, that is for this tutorial. I hope you liked. Hey there, and in this tutorial we're going to be creating a map which our players are going to be spawned in, and also have some spawn points so that they don't just get randomly instanced in the scene. So the first thing we're going to do is we're going to create the map. So we're going to hit new scene, and basically this map is going to be a node 2D, and we're just going to name it map. We're going to save it in the scenes folder as map.tscn. Next thing is we're going to create a color rect, and we're going to change the rect size to the size of our screen, which is 124 by 600. Then we'll change the color to any color of my choice. I'm just going to pick something random here. And the next thing is the tile map. So we're going to create a node called tile map. So in this tutorial, I'm not going to be teaching how to make tile maps. So if you want to learn, you can go over to my other video. Link will be in the description and at the card that they write here, where you learn how to make auto tiles. For this tutorial, I'm not going to be teaching that. So to actually make the tile sheet, I'm going to click tile set here, and I'm going to add tiles complete.png. So I'm going to add a new auto tile and I'm going to select this region. Then from here, I'm just going to actually speed up through this because there is no point going through all this. So for your information, this is actually a 64 by 64 bit style sheet, I guess. So that's the settings over here: step, X and Y, subtitle size, X and Y, 64, just so that you won't get confused. So from here, I'm going to speed up everything. So I'll see you at the end. So I'm done with the bit masking, and I just want to tell you a simple hack that I use most of the time when I'm working with style sheets, and that is when I'm selecting the bit mask,
I don't just select the color of the walls and all. So as you can see, I selected the empty spaces here, and that's what I just do most of the time for everything, just to save time. So basically, that's just a simple hack you can go away with. So now I'm basically done with everything, and if you notice I did actually select the styles. If you're following exactly what I'm doing in this tutorial, don't select the styles because they do actually treat our style sheets nicer and all. So basically just ignore these 7 tiles here. So with all that done, we can go over to the tile map and start placing our tiles. So now we're actually ready to start placing tiles all around our map. So I'm just going to place in the most obvious places like this, so that we can just have a bounding box there. And I'm just going to place some very random. Hopefully, I think that will be good. So we're going to have a spawn point here, here, and here. So that's basically all we need to do in the map. So if we save that, we go over to the script and over to server.gd. When we connect to the server, after we had the lobby, we connect to the server, then we want to basically instance the map there. So before we do that, we have to preload it. So up here, we're going to make a variable called map, and it's going to preload map.tscn basically. Down here, we're going to instance the map with map.instance and set the name to map. The next thing is we want to actually instance this map under a particular node. So now we want to instance this map above our nodes variable here. The reason for that is because if you don't, you see the map over the players and all that, which is not what we want. We actually want the players to be over the map. So to actually check where that is, if we run the scene now, so if we go over to the remote, we see that the global is the one that is above the nodes. So we want to put the map somewhere between this. So to do that, we're going to do get underscore tree dot root dot add child below node. So remember, we want to add it below the global. So we say global, and we can know that we're going to add, which is the scene. Basically, this is actually all we need to do to instance the map. So if we save this, we run this, also run our server. If we join game, you see that we have our player inside here and the map is all around and we can interact with it and collide. So for the next part of this tutorial where we're going to be doing the spawn points, actually I classify this as not being that much efficient, but just for the sake of time purposes in this tutorial, we're going to be using it. So we're going to actually find points on this map. For example, if we want this point to be a spawn point, we're going to drag over the ruler from the edge here. Down here, we're going to see like 288 by 144. And over here, if we want it to be a point, we make it 848 by 124 and all that. Just find points here and probably write them down or something. But actually, I already have points preloaded so that I won't have to be coming back and going back and forth to check. Please remember the one up is the x-axis, and the one on the other side, on the left hand side, is the y-axis. So if we go to our server right now, so up here we're going to make a variable called spawn point, and as I said, this is going to be our vector 2s, which are the positions and at the spot you want to make spawn points. So basically, I've hard coded all this in, and that's what you need to do. Next thing is we make a variable called spawn point clone, and it's going to be equal to spawn points actually, and you see why we did this in a minute. Then I want to make another variable taken points, and it's going to be equal to an empty array. And over here, just after the player connected function, we're going to make a function called choose spawn location. So now here we're going to just choose a random integer just to represent the index of the point we're choosing. And when we choose a particular point, then we're going to make a variable location, and it's going to be equal to spawn points in square brackets that point. So basically gets the point that we chose. And then basically we're going to append that particular location to the taking points, and we're going to remove that point from spawn point. Basically, it's just going to choose one of it, remove it, put it inside taking point, so that points will actually be acted like it's already taken. Then after removing the points, we're going to check the size of spawn points, and if it's less than or equal to 0, I don't know how it's going to be less than, but just for security purposes, so if it's less than or equal to 0, then we're going to reset spawn points to spawn point clone. That's why we made spawn points clone here, and taking points dot clear is just going to empty the taking points so that we can start the whole process over again. And lastly, we're going to return the location that we chose. Basically, this is all we need to do. Then go over to player connected, instead of passing in a hard-coded value here, we can just set choose spawn location, and it's just going to choose a random location and make sure people are not spawned there twice in a row, making it kind of rotate the spawn points and all that. So with all that being done, I think we're ready. But before I proceed, I'm just going to go over to the client here and go over to projects, project settings, go over to display, window, and down here we're going to set stretch mode to 2D and aspect to keep. The reason for that is so that when we run the scene here, when we resize it, it just kind of resizes it to the scale here. So I run this. So if I run this here, go over, run the server, and go over to another Godot instance and run it. I'm just going to resize this a bit. So if I join game on this side, you see I didn't just I didn't spawn at this point. I spawned here because that's the spawn location. If I join game here, you see that another guy got spawned at another location. And I'm just going to run more instances. So since there are four locations, it will have to exhaust all the four locations before it starts respawning again. So as you can see, you got instance at this point. If we join another game, it's going to get instance at the last point. And just for trial purposes, hopefully my laptop doesn't crash. We're going to join the last, and you see that it's going to throw us an error. So as you can see, division by zero error. Um, the thing is, spawn point clone equals to spawn points. Instead, we're meant to do spawn points dot duplicate. So we have to try this whole process again, but I'm going to speed through it. So just like before, I have five Godot instances. So I'm going to join game here, join game here, join game here, here, and here. As you can see, he actually shifted one guy so that it can instance itself again. That's actually the cycle, I guess. If it finishes the spawn points, it's just going to start again from the beginning. And these spawn points are actually random, so it usually goes in that manner, but that's not actually how it is. It's going to be completely random most of the time. Yeah, the game is looking quite empty, so the next tutorial we're going to be working on the shooting of the players and the dying and all that stuff. So if you like this, smash like. Thanks for watching. See you guys next time. Smash subscribe. In this tutorial, our players are going to be having guns, and as you can see, be able to shoot around in the scene. We have two different types of bullets, the green and red for the ones that is the player and for the one that is not. So we're going to be covering all this in this tutorial. If you're interested, stick around and I'll see you after the intro. So right now, to start with, we're going to make a player bullet, which is going to just be the normal node 2D, and we're going to name it player bullet. Then as a child of it, we're going to have area 2D, and as a child of that, we're going to have collision shape. This is just going to be the area of the bullet that is going to be colliding with things, so we can just call it box or hitbox. Again, as a child of the root node, we're going to add a sprite, and the sprite, I'm just going to give it the laser texture. Actually, this laser is from Kenny Assets. This is actually in the asset pack, so I'll go to the GitHub and update it. We're going to save it as playerbullet.tscn inside the objects folder. And also, since it's the player bullet, I would not like it to be a red texture. So I'm just going to go ahead and give it a green one. So that's better. The collision shape is going to be a capsule shape, which is the size of our bullet here. So that will be good. Just extend this a bit. Then we're going to create another object called otherplayerbullets.tscn. And the reason for this is because they are, as we have our other players, we're also going to be having our other bullets. So we can go to the player.tscn and duplicate this. And here we're just going to name it otherplayerbullets.tscn. Last thing we have to do is on the player bullets, we're going to add a node called timer. And this is just going to be keeping track of how long our bullet has stayed in the game so that we'll know when to delete it. And over here, wait time, we're going to put that on the 5 and auto start. So actually, pardon me because I make this mistake a lot. Our player is actually is facing the right hand side right now, and our bullet is facing up. If you try to instance it, we're going to run into some problems where we see the bullet shooting the direction that I'm moving the mouse here, which will not be nice. So actually what we're going to do is we're going to rotate the sprite. So we'll go back to sprite transform, and we're going to rotate it 90 degrees, and also go to the collision shape and rotate it 90 degrees. So then we do the same thing for the other player bullet. We're just going to rotate the sprite 90 degrees and the collision shape. Remember when I say we want to give this other player a different texture? So we're going to drag over this red here and put it there just so that we can differentiate which one the player shot and which one the other players shot, I guess. So with all this done, we're going to add the script to the player bullet. We're going to save it in the object player bullet.gd. So the first thing we're going to do is we want to declare some variables. First one is going to be velocity, which is going to be a vector to the right. As I said, the orientation of our bullet is to the right hand side. That's why our velocity is to the right by default. Then we're going to have a player rotation and a speed. The next thing is on the process function, we're going to add velocity times speed times delta to the global position. That's just going to make it move to the right hand side by default. But before we call the process function, on the ready, we're going to make visible to be false and we're going to wait for the idle frame. After the visible is set to false, we're going to wait until, okay, the next thing to do is call the process function. Then we're going to change the velocity to velocity that rotated in the player rotation, and we're going to set the rotation to the player rotation, and we're going to set visible back to true. Basically, if you're not making a game production ready, you can actually get rid of this line because it doesn't really matter, but you have to compensate for people's devices lagging and all that stuff. So that's why we yield for the idle frame first. And after that, we're going to go over to the timer, go over to node, and we're going to connect the timeout signal here. So basically what we want to do is after these 5 seconds of wait time, then we just want to delete the bullets. The reason is we don't want our bullets from here reaching the other end of the screen without actually disappearing or something, like just kill anybody from any spot. So we actually destroy the bullets. You can make this wait time smaller if you know your map is a bit smaller. You can make this to like a 2 seconds, or I don't know if that's too small, but anyways, for this I'm going to leave it as 5. Then for the last thing we have to do with the player bullet, the hitbox, we're going to go over to node and on body entered. So when we collide with the body, the timer, the a player, whatever, we want to delete ourselves from the scene. So basically we just call on timer timeout. Actually, I didn't even explain what this is doing. It's actually sending an RPC call to the server that, okay, destroy this particular bullet and the name of the bullet. And we're going to be setting the names later on such that two bullets cannot have the same name and all that stuff. So our other player bullet is going to be somehow the same thing with this one. So I want to show you a quick hack. So here in my rest directory, I'm going to create a new folder and I'm just going to call this classes. Inside classes, I'm going to make a script and new script. I'm just going to call this bullets. So on bullet.gd, this is going to be a class. So now to make a class, you just do class underscore name and it's going to be equal to the class name. So I'm going to just put this as bullet. So now we'll go to our player bullet.gd. We're going to copy from here upwards. And over here in bullets.gd, we're just going to paste it inside there. Now, as you can see here, it says visible not declared in current scope is giving us an error. So I made a mistake. This is meant to be node 2D, not just a node. So with that done, we can go over to the player bullets now. And actually, instead of extending the node 2D, we're just going to extend bullet. And funny enough, it is going to import all these attributes, all these properties inside there, and it will work perfectly. So now if we go to our other player bullets.tscn, we're going to first of all rename this to other player bullets. Yeah, I think I got the spelling wrong there. And we're going to add a script. Over here, as you can see, inherits, instead of putting in node 2D, so I'm going to click this icon here and I'm just going to search bullets and it's going to inherit the bullets right now. So I'm going to hit create. As you can see, it extends the bullet class. Actually, there's nothing long to do in this particular script. Just on the hitbox, we're going to connect the area and body entered, and the same thing, we're going to delete the bullets from the scene. You may be asking yourself, why are we deleting it from the other player bullet and also deleting it on the player itself? And this is actually quite complicated, which I can't even explain without a drawing or something. But basically, just know that if somebody's computer or somebody's device is hanging and probably the frame rate is low and all that, it's going to actually affect everybody playing the game, which means bullets will be deleting at points they're not meant to delete and all that stuff. So in order to keep everything kind of in sync, we're going to delete it on both sides here. If you don't understand anything I just said, just forget about it. Just follow my lead. Right now, we have prepared the other player bullet and the other player bullet itself. So now it's time to actually instance these guys. So on the player script, I believe I've covered this in many of my tutorials. This is basically just top-down shooting. First off, we're going to make a variable called can shoot, and it's going to be equal to true by default. And over here, if we can shoot and the select button is clicked, Then we want to tell the server, oh, we have clicked and want to instance a bullet, so instance for everybody. And we're going to send the rotation of the player so that it know where to instance it and how to move, and the global position of the muzzle at that point in time. So after that, we set can shoot to false. We're going to wait 0.3 seconds and allow you to shoot again. Basically, that's simple stuff. Tell server to instance bullets, set can shoot to false, wait 0.3 seconds, and allow to shoot again. So we're here in the server script, and first of all, at the beginning here, I just want to make a variable obj underscore idx, basically object index, and for this it's going to be 0. I'm going to be explaining why we're using this object index soon enough, but right now just create that variable. So now remember that on the client's player script, we're going to be telling the player to instance bullet, so that's the function we're going to create. So in here, we're going to create a remote function instance bullet that contains player rotation and player position. Then we're going to get the particular player that sent it using get rpc sender id. Next thing is we're going to send an rpc call. So basically, just look at this rpc call like rpc id 0. Basically, both of them are just going to broadcast to every node. So I just said let me use rpc since we've been using rpc id too much. So I just want to tell you that rpc is basically the same thing as rpc id 0. So we're going to tell everybody on the network that they should call instance new object. And here we're going to send the player that sent it, which is player ID, and this long string. Basically, it's just going to combine the player ID with this string bullet and also this object index. So now the first bullet that's going to be shot is going to be 0, and the next one is going to be 1, 2, 3, and it keeps getting bigger and bigger. So the reason for this is, first of all, we can keep track of who sent it and what number that is, so that we won't be having two the same nodes or two the same bullets with the same name ever. Then after that, we want to set the player rotation and player position also. Last thing is we want to set object index to plus equals 1. That's why I say you can never have the same number again. So we always add it by 1 and all that stuff. So now with that being done, we want to go and create this instance new bullet function on the client. So over here in the client, on the server script, we're going to create a remote function instance new bullet. We're going to take in the ID, the bullet's name as we sent, the rotation and position of the player at that point. Also, you may be asking yourself, why do we have to send the rotation and position? Why can't we just send one of them? And the reason is, what if the player on one side is having some network issues? It's going to actually send wrong positions, which is going to make the bullets have to have their own positions and rotations where they are going to walk from. Because if they don't, you'll just see bullets. Probably somebody shoot a bullet at this side and it's actually going this other way. And before we continue, we want to just go up here and preload the enemy bullet and bullet scenes. So we'll come back down here, we'll create a variable b, and it's going to be equal to bullet if get unique id is id, else enemy bullet. Basically, this is checking if we are the ones that shot the bullet, then instance the bullet node, the player bullet. But if we're not the ones, instance the enemy bullet. This is actually the same line that is here, but this time around for the bullet. So after this, we're going to instance the bullets using global.instance node, and we're going to just instance b, whatever b is going to be, and we're going to instance it as a child of the nodes and at the current position. Then we'll set bullet instance the player rotation to be equal to rotation. Remember, in the bullets.gd class, we have something called player rotation, so that's just going to set the rotation nicely. Then we set the bullet instance's name to the bullet name, and this is going to be useful especially when we're going to try to delete it from the scene after some time and all that. So I'm sorry I didn't explain the muzzle, what the muzzle is. And yeah, in the player.gd, we actually reference the muzzle here. So the muzzle is basically going to be the point where the bullet is meant to come out from. And we haven't made that, so we're going to make a position to the node. And we're just going to rename it to muzzle. Then we're going to move it over. I'm really sorry I didn't explain that, and I'm actually explaining at the end here, which doesn't make so much sense. But anyways, now you get it. This is actually a payback for people that don't watch to the end of the video. So always watch to the end of the video. So with all that done, I think we're ready to run the game. So over here at the client, we're just going to run one. On the server, we're going to run this, and we're going to run another Godot instance. So over here, we join game. Both of them are currently inside, and as you can see, as I shoot, on this client is going to be green, on that other one is going to be red. And yeah, I can actually shoot really nicely.
But as you can see, it's not destroying when he hits a wall or something, or even when he hits the player. So that's because we have not created the destroy bullets function on the server. So that's what we're going to go do now. So actually, what we have actually told the server to delete bullets at many points in time, or at shall I say different points in time. So the last step is to go over to the server. I'm going to add a destroy bullet function, which is going to be a remote function because we're going to be calling it from the client, and it's just going to say delete objects with the bullet name. And remember from the previous tutorials, or I think the last tutorial, we made a delete objects function which takes in an ID, and it checks if the nodes has that ID, then it just delete it. Basically that's all. So now we're going to run two Godot instances again, and we're going to join game on this side, join game on this side. As you can see, they are in here, and if I click the spacebar button, the bullets actually delete when they touch the down map and all that. But this is definitely not looking good. As you can see, it's actually entering inside the down map. And we're going to actually focus on that in a different tutorial, at least just to avoid it from entering the timer before it deletes itself. And right now, if we hit the player, you can see that it actually still deletes from the scene. But right now, our player cannot take in any damage, which is what we'll be doing in the next tutorial. So I think that's all for this. Thanks for watching. See you guys next time. Smash it. Hey there guys, welcome again, and in this tutorial we're going to be making sure that the player can kill another player and is going to respawn. And also, if you kill a player, it's just as if it's no more there, and you can pass through him and all that until he respawns. If you're interested, stay tuned, and I'll see you after the intro. So we're here now on my whiteboard as usual, and we have a client A and a client B. So when this player kills this other player, for example this guy dies, what exactly happens is we're not going to be deleting the node because reinstancing it will be a lot of work. So we'll just make it disappear just temporarily, and after the respawn timer is done, it will reappear back just as if nothing happened. Basically, that's the workflow we're going with, and I'll see you in the tutorial. So we're going to start off this tutorial by going to the player script, and over here at the top we just want to make a variable called HP, and it's just going to be equal to 100. Basically 100 is the hit point of our player, so if we want to damage him, we're going to just reduce this hit points basically. So over here we're going to make a damage function which is going to take in a value, and we'll just say HP minus equals value. Then if the HP is less than or equal to 0, then we want to tell the server that, oh, this player is killed. But if it's not equal to 0, then we're just going to say, okay, damage the player. In this tutorial, we're going to be sending packets really frequently because we want synchronization with the players and their hit points and everything. So the next thing is we go over to the other player bullets. Then over here, we're just going to check if the integer version of body.name, that's like the current body that he hits, if you turn it to an integer, if it's equal to our current ID, then this is us that he hit. Then we're just going to say body.damage 25. And as I said in the player here, it's going to call the damage function, pass 25 as the value, so HP minus equals 25. And if you do the math, that means if 4 bullets hit us, then we're going to die. So with all this done, it's time to go to the server. Now over here, we're going to create a remote function, player damage, which is going to take in the remaining hit points of that particular player. Remember where we sent it over here, player damage, HP, we're sending the current HP of this player. And I'm really sorry, I forgot something. In other player.gd, what we need to do is going to set HP also equal to 100, just so that the other players are going to have 100 by default. So when we call this function, we're going to get this player that sent it, and we're going to send, and we're going to tell everybody that, oh, this guy has been shot, so update his HP. That's why we're passing in player ID and the remaining HP here. So we go back to the client, and in the server script, scroll down, and just after we instance new bullet, after the function here, so on the player damage function in the client, so we're going to set p to the node that just got hit. As you can see, nodes.get node that ID. Then we want to check if it's not us, then we want to set p.hp equal to hp. Then after that, I actually like this very cool lightning effect, just as if the player is turning all white and all, so that I can just give it a feel there. So I have to actually add this coding. So basically what we're doing is manipulating the modulate property. So as you can see, previous modulate equals to the current modulate of the hit player. Then we want to manipulate the color to be 5551. Basically this means all white. Then we're going to wait 0.1 seconds for a timeout, and after that we're going to set p.modulate back to previous modulate.
If you're not a beginner, I actually feel you will understand this code. But if you are, you can actually just play the video back and hear me explain all this over again. Or if you just wonder lighting effect, you can just copy this code. So with that being done, we're done with player damage. Then remember, if HP is less than or equal to 0, then we want to kill the player. So we also have to do that. So we go back to the server and just under the player damage here, we want to set player killed, a player kill function, which as usual gets the player that sent it and also tell everybody that they have killed that particular player. We go over to the client, go over to the server, and just under player damage here, directly under the function, we're just going to set killed player to the particular node that they killed. Then we're just going to get the shape of that node and set it to disabled, whereas disabled equals to true, and also set the physics process of that node to false. So this get node shape is not actually meant to be shape, it's meant to be collision shape. So we're going to go over to other player.tscn, other player.tscn, and the shape we're just going to rename it to shape and go over to the player.tscn also and rename this guy to shape. Then after disabling the player and setting the physics process false, then we just want to hide the node. So now we can run this, we can press play here, and we'll also run the server. And as you can see, when we shoot this guy about 4 bullets, you can see it's flashing there. It just disappears. And if we go close to him, we cannot actually interact again because we disabled the collision shape and all that. So now the problem is, as that guy is gone, he can't come back anymore. So we have to make him be able to respawn, and also probably put some kind of fill screen over his screen here. So first of all, we're going to start by making the fill screen. So we'll go over to scenes and map.tscn. So in the map, first off, we're going to add a color rect, and we're just going to increase this to the size to cover the whole screen there. Then we're going to set the color to black, and alpha, we're going to turn it down a bit. So we're going to rename this to fill, and as a child of it, also we're going to make a label. So the label is just going to say respawn in 3 seconds. I'm going to just set the fonts and make everything look nice. As you can see, I think this is good. Just place it in the middle there and do the 3 dots behind it or something. And basically, you can actually make this respawn in 3 seconds to be counting down. But I don't want to actually make this tutorial unnecessarily long. So I'm just going to leave it like this. So if we go back to the server.gd, under here, we're going to check if the ID of the player that died is equal to our ID. Then if it's ours, then that means it's us that died. So we're going to get the failed node and just show it. And the failed node is just that failed screen that we just created. Yeah, in fact, by default, the visibility is meant to be turned off. Then we're going to wait for 3 seconds using yield.getTree.createTimer3. And we're going to wait for the timeout. So after 3 seconds, we want to hide the failed node. And for the last thing, respawn the player. So this is going to tell the server, okay, I'm done with dying, respawn me, something like that. And it's going to give it the ID of itself so that it can respond. So we're here on the server and we're going to create a respawn function, also remote. We're going to be calling it from here. So it's also going to say respawn player, and it's going to respond an ID, the our current ID, and choose spawn location. So since we didn't delete the player or anything, respawn player is going to just be resetting everything that we set here. So as you can see, if nodes that has string ID, that means if we are there, I guess, which means if we are still around, probably if we didn't disconnect or something. Then player is going to be equal to our node. Yeah, it's going to get node the ID. Set the global position to location, which is actually a spawn location called from this function up here. Then we're going to get the shape and set the disable to false so that we can interact with it again. And set the physics process to true. Set HP back to 100 and show the player. Basically, this is all. I think we're going to run this, run the server, and run an extra client. So just click join game here, join game here. As you can see, we are in. And moment of truth, if we shoot this guy, I think 4 bullets. He died responding in 3 seconds. And he actually respawned at the spot, which is nice. Anyway, yeah, before I forget, if you notice, the spawn locations actually goes in this manner, and it always goes in that manner. And the reason is, over here the server, we are not actually ever randomizing, so it follows a particular pattern basically. So on the ready, every single time we load the server or something, or if you are doing this for a production ready project, every time we choose a spawn location, then we just want to randomize. Basically, this is going to make the spawn locations to be always random. So we're going to close both of these, I'm going to restart the server. I'm going to load this up twice. So if you join game on this, join game on this, as you can see now, they got instance at two random positions. And if I shoot this guy, after that he's gone. I can't interact anymore. And you see that he appears on this other side. Let me just go and see, show you that I can actually touch him. I can't pass through him and all that. But the moment I kill it, or kill it, he's no more there. I can interact again, and he responds somewhere different. Basically, I think that's all for this tutorial. We have successfully spawned them in different locations, which is crazy. So yeah, I think that's all. Thanks for watching. See you guys next. In this tutorial, we're going to be keeping track of how many kills a player has killed and who has the current highest kills in the game. So if that sounds interesting, stay tuned and I'll see you after the intro. So getting started, I want you to create two nodes. This is the kills and the highest kills. So this is going to be keeping track of how many we have killed and how many has the highest person in the map killed. As children of it, make counters. So it's just going to be label and also have probably the same font. So we're going to make one for kills and one for highest kills. So with that done, I want you to go over to the server and on the script here, over here, the bullet, where we're assigning the name we want to give to the bullets, we want to add something else. So we're going to add idx. So now instead of our bullet name looking like this, it's now going to look like this. I'll explain the reason for that in the next step. But mostly it's just so that we'll be able to strip this player ID, or we'll be able to get the player ID quite easily. Because we want to be keeping track of who is the person that shot it, who is the person that killed who, and all that stuff. So back in the client, and we're going to go to player bullet, sorry, and other bullets.tsm, and we'll go to the script. And over here, where we are passing the damage, we also passing the name of the bullet. This name, remember, it carries the person that shot it, the object, and the object index. So go over to the player, and over here where we call the damage function, we're just going to add a comma and bullet name. So now this bullet name is not going to be useful all the time. It's only when the player is killed. So the person that shot the last bullet that killed the player is probably the killer, I guess. So we're going to make a variable called killer, and it's going to be equal to an empty string. We're actually going to loop through a range of characters, the length of the bullet name minus 6. And the reason is because since we have bullets in front of the name, then we have to remove that bullet, and which is 6 characters. So as you can see here, if bullet the name plus I, 6 plus I is a valid integer. So if we start counting and we see that okay, it starts with an integer, then add killer plus equals to bullet name 6 plus I. That's basically just going to add the letter there, and that's how it's just going to go in a loop until it gets the last integer. So now that is actually the reason why we added idx here, because when it checks after it finishes checking and sees all the long player id stuff, then it's going to check I, and I is definitely not a valid integer. So it's just else break and close the loop there, and, and basically that's it. So here when we say player killed, server rpc id 1 player killed, we're also going to send the person that killed. So we're going to send the killer. So with all that done, we are ready to create a function in the server. So we are here in the server, and up here we just want to create some variables. First of all, we're going to create kills, and it's going to be equal to a dictionary. Then we're going to make a variable called highest, and this is the person with the highest kills, and it's just going to be equal to 0 by default. Then we want to add that player to the dictionary. So we say kills str id equals to 0. Basically sets whoever is coming newly to 0. Then on the disconnected function, here we're just going to say kills dot erase and id. So we're going to remove the person and his score from the dictionary, basically. So with that done, and over here on player killed, we're just going to be editing some things. Remember, from the client we're passing also the killer. So over here we're also going to pass in the killer. Then after we get the player id, then kills killer plus equals 1. Basically add 1 to the number of people that the killer has killed. Then we're going to check if the person that killed right now has the highest kills. That's by just saying kills killer greater than highest. Then we're going to send an rpc call to everybody that okay, there's a new highest, update it. Then we're also going to send an rpc call to the person that killed and say okay, update your own kill. So you can actually do this on the client side, but as I said, for synchronization, the server has to do everything, I guess. So instead of sending it to everybody, we just send it to int killer, which is going to be an integer version of the killer. Then it's going to use update skills to update the current kill count. So with all that done, it's time to go back to the client. On the client here, we'll go back to server.gd. So all these functions that the RPC calls, we're going to have to create them. But before that, I want you to go back to the map.tscn, and I want you to create a script to this map. So in here, we're just going to have two functions. The first one is going to be update kills, and in here we'll pass in the number of kills. And in this function, basically we're just going to say kills the text equals to a string version of the number of kills. Basically, that is all you need. And also the kills and the highest kills are going to be under the player. So to fix that, we're going to add a canvas layer node and also put the kills and highest kills as a child of it. Then we go back to the script, and instead of just passing in raw kills, we pass in canvas layer slash kills. Now also, it's not the kills we're updating, it's the count. So kills slash count. The next function is going to be similar to this, so I'm just going to copy it and paste it. And this one is just going to be update highest, and here I'm just going to pass in highest kills count the text equals to string kills. So with all that done, I think we're good. We go back to the server, and here on the remote update kills function, it's just going to get the map and update kills with the number of kills. And the update highest function is just going to do the same thing by updating the highest with the number of kills. Hopefully we are good. I'm not sure, we might run into some errors, but it's worth testing. So we hit play and we run on the server too. So as you can see here, I got two instances open. I'm going to join on this side, join on this side, and I'm going to go over here and kill this guy. And yes, my kills got updated, but the highest didn't get updated for some reason. I'm going to go back and check that, but let's just be sure. I'll kill this guy too. Yeah, the highest isn't updated. And actually, I'm sorry, my bad. I forgot something. Instead of just sending the highest, as you can see, we're not incrementing the highest anywhere. So we're actually meant to say highest plus equals 1. Or to be more precise, we do highest equals to kills killer. So that's the highest person that. So that's the number of kills that the highest person has killed. So we're going to run this again to be sure. Go over to the client, run it. So this time around, I have 3 instances open. So I'm going to join game on the 3 of them. And over here, I'm just going to kill this guy. As you can see, highest got updated everywhere, and my number of kills is 1. So I'm just going to try killing about 2 people. As you can see, highest got updated. If another person kind of gets in the mood and kills more than, as you can see, he updated to 1, but the highest is still 2. Then we come back here and kill this guy. You can see highest got updated to 3. Yeah, basically that's how to implement some score count system. Actually, to do this at first I was scared.
Hey there everybody and welcome. This is the last tutorial of this series and I'm really glad to be here right now. So in this tutorial we're going to be hosting the game on a VPS just so that players from around the world can come join and play with everybody, I guess. So before we begin, I want you to just go over here to DigitalOcean and I want you to create an account. So this is actually the service that we're going to be using for our VPS. We're going to be creating our VPS here, and they give a free $100 credit when you just sign up. So you can go over to the link in the description, sign up, get your $100 credit, and try this out for free. And one bug that I've seen when you're trying to sign up is don't try to sign up from Google or from GitHub. Just try putting your email and password there and sign up. And don't worry, when you try to sign up, they're going to ask you for your payment details through PayPal or your card. Just put it in, they're not going to debit it as long as you don't actually spend the money on the server. So I'm going to give you like 3 seconds so that you can go create your account and come back. So now to begin, we're going to go over here. When you just create your account, this is what you're going to be seeing. This is going to be your default. I think the name will be droplets, whatever it is. So but this is exactly what you're going to be seeing. So first off, we're going to click create, and over here we're going to click droplets. So when you do that, you're going to see create droplets, choose an image, and all that stuff. So we're going to leave it as Ubuntu. I'm going to leave it as 20.0.4. And here you see choose a plan. You can choose the shared CPU, general purpose, CPU optimized. You can actually go for the craziest one right now because you're going to be using your $3 credits, I guess. But whatever, I'm going to just go to basic, this shared CPU, and I'm going to click this $14 one, I guess. Or you can go for this one since it has 2 Intel CPUs. Just If you're doing this for production purposes, just go for the one that is best. So over here, you see add block storage. We're not going to add that. We don't have any databases and all that. I'm going to choose Amsterdam for my country because I don't know why not. And yeah, that's it. Password, you're going to choose a password. I actually like using one particular password because it fits all these criteria inside here. So I'm just going to paste it, and you can see password must be this long. Just make a password to fit this criteria. Make sure you remember that password because we're going to be using it later on. The next thing is select additional options. You can select to enable backups. This is just going to be backup the server's data, monitoring, all these things. This one is free, IPv6. We're not going to be using IPv6. We're just going to leave all these things blank. And over here, how many droplets? We only want one, and we can just choose a host name. In this case, I'm just going to choose multiplayer, or let's just say Godot multiplayer. So yeah, here you can choose tags. We're just going to leave that blank. We don't actually need tags, and the tags are just so that in case you have like many droplets, you can shuffle through really easily. So we're going to select the project, which is the droplets project. I'm going to click create. As you can see, it's creating our server here, 2 gig 60 gig space in the disk, and we're just going to wait for this to finish. So yeah, we were done with that. As you can see now, our server has been created and it has an IP address. We're going to be using this later on, but before we go on, you'll have to download FileZilla. So FileZilla is basically what we're going to use to transport our game project or our server file to the main server here, the computer. So go ahead and download FileZilla. Go to filezillaproject.org/download.php. You're going to see for Windows, you're going to see for Mac OS down here, Linux, whatever operating system you're on, and get it. Also, just to be clear, make sure you get FileZilla clients. Please don't go getting FileZilla server because you won't be able to follow along. So after this, we're going to go over to our server, our Godot server here, and we're going to export it. So we go over to projects, export, and as you can see, we have a Linux already in here. If you're not seeing that, just click add and click Linux 11. And we're just going to leave all these values default. And make sure you don't click this embed pack because where is the pack is the PCK file we're going to be using. And before we continue, I want you to take note of something. I want you to take note of the current version of Godot you're using. For me, I'm currently using Godot 3.2.3, if I'm not wrong here. If you want to check, you go over to help, about, and you're going to see it here. Godot engine 3.2.3. So yeah, take note of the Godot you're using to export this because we're going to be using it later on when we try to deploy the server. So we'll go back to project, export, and we're going to click this and just going to export the project, and I'm going to export it over here to multiplayer game. I'm just going to export it here. So click save. Going to take a couple of seconds and we're done. So if I go back to that folder here, you're going to see server.x86_64 and pck. Actually, we're not going to be using this other one. Is the pck file we need, as I said before. So now I assume your FileZilla has finished downloading, so we're just going to go fire it up. So when FileZilla is up, this is basically how it will look. It may not look like this. I'm kind of using an old version because I don't know, I don't like trying new things. But anyways, when your FileZilla is up, it's going to look like this. So we're just going to navigate to that folder that we saved, that server that we just exported. So mine is in desktop and is in multiplayer game. This is it, and these are the two files down here. So now we're going to be connecting to this DigitalOcean server that we just created. So we'll go over here, hover around this IP address, click copy, and go back to FileZilla. We're going to click this Open Site Manager, and over here, my site, you're just going to click New Site. When actually, this is not actually a site, but just click New Site. We can rename this to Godot, and we'll go over here to Protocol, choose SFTP, and the host is going to be the IP address we just copied. We're going to leave the port empty, and the password is going to be that password that you set while creating this server. So remember I told you that you need that password. Now this is the time. We're also going to use it again later on, but you're going to paste in that password here. So over here for the user, we're just going to use root, and we're going to click OK. Then we go over back here, and if you click this drop down, you're going to see Godot. We're going to click that, and it's going to try to connect. As you can see, it's going to try to connect with this fingerprint, all this stuff. Just click OK, and as you can see, connected, retrieving the directory. And here it is. This is our this is our server that we created on DigitalOcean. So now we're going to be sending the server.pck file. As you can see, it's now inside there. So basically what I just did is just drag and drop, basic drag and drop to just upload the file to the server. That's actually everything we need FileZilla for. I'm sorry if it was a pain in the ass to download, but whatever. So now it's time to log into the server and do some cool command prompt stuff. So we're going to close FileZilla and we're going to open Windows Terminal. You can open Terminal, you can open command prompt, whatever you want. But I'm going to be using Terminal in this case. So now I'm open here in my terminal and this is where we're going to be doing the remaining stuff. Before this, I just want to make reference to this website. This is actually where I found how to host dedicated servers for Godot. Kudos to Coding Kaiju. This is an amazing article and you also check it out in the description below. So we're going to be connecting via SSH. So first off, we're going to type in SSH and we'll say root at that IP address of the server. So hit enter on that and it's going to say the authenticity of the host, blah blah blah, can't be established, fingerprint, plenty weird stuff. We're just going to say yes anyways. And now they're going to be asking for the password. Remember that password we set when we were creating the server? That's the password we need here. So go ahead and copy that in. If you type in the password, you're actually not going to show it. So just use your blind mind, I guess, and just type it in. And if you hit enter, if the password is correct, you'll be successfully connected. As you can see, root at Godot multiplayer, and this was that name we set when we were creating the server itself. Here it is. So if you have gotten to this point, trust me, you're going to finish this tutorial with ease. So over here, I can just type ls and you're going to see server.pck. So now the next thing is we're going to be downloading the Godot headless server, headless Linux server, and we're going to download it through the terminal. So I'm going to paste in this in the description so you can go ahead and copy this same command. Basically is wget, and this is actually where the server is stored. Remember when I said you should take note of your Godot version? Yeah, this is why. As you can see here, 3.2.3, just change that to your version. And over here, Godot v 3.2.3, also change that to your version that you're using. Every other thing can remain the same way. I'm going to go ahead and download it. And what does it say? Command get not found. Oh, sorry. Before this, we're meant to do sudo update. Oh yeah, sorry, I just tried to wrap my head around the error. And what we're meant to do is sudo apt update. Basically, is to update the Linux server, I guess. Next up, we're going to be downloading Godot headless server version. So for that, I'm just going to paste in this command wget, and this is basically going to download that Godot headless server version. So if we hit enter on this, you'll see it's going to download it a couple of seconds, about 18 MB per second. That was crazy. So we're done with that. So as you can see, we downloaded a zip file. If we type ls, then we can see the file we just downloaded, and it's a zip file. Before we can extract this, we have to install something, and to do that we just do sudo apt install unzip. As you can see, it installs it really quickly, and now we can go ahead and just unzip that Godot file. All these commands will be in the description below, so don't panic. And now for the finale, if we type ls, we're going to see that we successfully extracted it. So now we're going to run the server file. As you can see, Godot v 3.2.3 stable linux server .64 dash dash main dash pack fps server .pck. This is actually meant to be server. This is the name of your server. So yeah. So now, moment of truth, if we hit enter, wow, you're going to see a lot of errors. So now, these errors don't actually matter in my opinion, because when I searched online about the errors, they said that it doesn't really matter. Anyways, as you can see, server created has been printed successfully. And now, in order to connect to our server from the client, go over to our game script here, go over to script, that's server.gd. Over here where we put 127.0.0.1, instead of connecting to that, now we connect to a real IP address. So now if we go back to our game and we click run, moment of truth, if we click join game, yeah, we are in. So if this doesn't work for you, I want to just tell you some problems. As you can see here, player connected. So if this doesn't work for you, make sure you are running the same version of Godot as the one that you exported the server in. Make sure, because I have like 7 versions of Godot also, and most of the time I run it on different Godots, and I've always had that problem. So make sure that you're running the same Godot version so that I can connect. So now I'm just going to create another Godot instance so that you can see people working in the scene and all that. If you join game on this side, you can see the other guy got spawned. And if you look closely, you're going to see some latency. And that's actually because we're no more on our local machine now, we're on a server. So if we move, you can see a bit of lag there because my internet is not that fast, but it's fast enough though. Anyways, as you can see, I'm just going to try to kill this guy. As you can see, responding in 3 seconds, everything is working. Basically, everything is working. But wait, there's actually one last thing we haven't done. If you go over here back to the command line and we close it, as you can see, I'm trying to shoot, I can't shoot. That's because I'm disconnected from the server. So closing the command line surprisingly disconnects you from the server. So we are going to have to fix that. As you can see, we have gone back to the home page because the client now knows that we're disconnected. So I'm going to open up terminal back. I'm going to log in, and instead of running it like this, if you want to get out of, if you want to stop this process, you can just click Ctrl C. But instead of running it like this, I want to run it in the environment so that even after I close this terminal, it's still going to run. So we're going to be using nohup for this. So nohup is built into Linux, so you don't have to install it or anything. So just put nohup in front of the run statements, click enter, and you're going to see nohup ignoring output inputs and appending output to nohup.out. That is basically just going to append all the errors to nohup.out. If you want to see that error, you can just close this and do nano nohup.out, and you're going to see all the errors. And remember, it's just like those errors that were there before. Then we're going to use Ctrl X and exit out of that. Come back and run the nohup again. As you can see, same output. Then if we close this, we can go ahead, run our client, join game, and as you can see, he joins the game. Also run another instance, and as you can see, join game. Yeah, so everything is updating really nicely even after I've closed the terminal because it is now running that file in the environment. So yeah, I think that's all for this tutorial. I'm really thankful to all of you that have watched this tutorial series from the beginning. It means a lot to me. And I really thank you for watching this video, even if this is the only video you have watched. Thanks again to you guys. Thanks for watching. See you guys next time. Smash subscribe and goodbye.